everybody, how are we doing? We're actually here for the right time for office hours. Gosh, time is just so busy. It is, I thought this morning we had problems with the internet, and I was like, well, I'm going to be late to office hours. And then I realized office hours are later in the day. So with that, we're going to get started here on working with some, I believe, probably some 201. If you're in the chat, feel free to say hi. Just swing by and get some work done. I think when the assignments are closer to due, more people come by. A little chilling music while we chill here. Chilling, doing some work. Chilling, doing some work. Let's go check it out. Stats work. Anyone here? My hair just keeps getting longer. It happens. It happens. Let's go over here to stat 201. So many things. Got like 8 hours of sleep last night. I think I need more coffee. Always more coffee. It's the answer to all. Coffee, coffee, coffee. It's like the shirt. It's glowing a little bit. Assignments. Let's look at a little more chapter 3. When is chapter 3 due? For 201. Ooh, it's due tomorrow? It's due tomorrow? Let's go to replace questions. Okay. We don't have anyone in here and it's due tomorrow? Scary times. Maybe I'll throw an announcement. Who wants to work in a little chapter 3 quiz? Go to Discord. Main screen. IQR for the histogram. And the quiz time is less print. They're saying it doesn't. Okay, cool. Let me help out with this. We put it in the notes of the video. And let's do data analytics. Okay. Where is the time? It is 4:53. Stat 201. Data analytics 2, interpreting the IQR or interpreting summary statistics. Okay, let's do it. So summary statistics are how we summarize data, hence summary statistics. To get summary statistics, we have to do some analysis on data, and then we have to know the proper summary statistics to use. So we're going to pull up the Pokemon data because everyone knows Pokemon is the best. And when we do an analysis of data, we have to understand we're working with categorical or quantitative variables. So first off, let's talk about categorical data. When you're doing categorical data, it's something in JMP especially that has a red icon. Now this will have different levels to it. There's multiple types of Venusaurs, Mega Venusaur, all those different ones. It's almost an identifier. We got different Charizards there. But we're going to stick to something a little bit easier like Legendary right here, which only has 2 levels. Are they legendary or are they not legendary? Once again, this is a categorical variable, and to graph it, and I'm going to show you a different way here in a second. Well, this kind of shows the assignment a little bit, but we can go to Graph and Graph Builder and drop the variable inside of here. When you drop it inside of here, you get the variable inside of here, and you need to then graph it by choosing either a bar chart or pie chart right there. Bar chart, pie chart, bar chart, pie chart, bar chart, pie chart. You can also add the labels, which I do suggest, by adding the labels right there. And then when you're done with it, make sure to click Done. You can tell that there's 65 legendary Pokemon, which is 8.13%. out of the total Pokemon that exist in this data frame, and there are 735 non-legendary Pokemon. You can see the false right there when you highlight it. Click Control or Command and select the data if it is selected to deselect it. This is a categorical display of data. It is a pie chart. Now, preferably when I make bar charts, I like to go to Analyze Distribution. Analyze Distribution is used to analyze univariate data right there. And now we double click Legendary, and it goes right there to the Y columns for the analysis, and we click OK. Now, the first thing I do when I get right here is I hit the Stack button to put it in horizontal layout. And then I like to add in a count axis to it by clicking the second red arrow, Histogram Options, Count Axis. There's other things you can do to it. You can also go right here and go to the second red arrow, Histogram Options, and make it a nice light purple right there. It's all preferences at this point. Making it a little bit bigger to make it more viewable, all these great things. So now what you'll notice, this is the same data displayed just a little bit differently. And the summary statistics, which is basically summarizing the variable at the top of the screen right here, tell us the same information we see in the pie charts. So pie charts and bar charts are just ways to analyze univariate categorical data. You can see them up there. We don't like some ring charts. Pareto is a bar chart put in order. And the frequency table is actually on here too. You can see the frequency table right here and the relative frequency over here. It's just showing you the data different ways. That's all these things do. They summarize the data. So that's how to summarize categorical data. It's pretty simple, pretty easy, not too complex. Little more steps when it comes to, so we'll put right here, interpreting or categorical summary statistics. We're going to go over to quantitative summary statistics. And if anyone's watching, feel free to ask questions. Stat 201, data analytics 2, quantitative summary statistics. Now, when we do quantitative descriptions of data, we first talk about the shape. The shape is just how the data looks. We do shape, center, spread. And the reason we do these, and it might be a good idea to indent, because center and spread are 100% based on the shape. So we first determine the shape right here. And if the shape is going to look more normally distributed, more like a unimodal symmetric distribution, which would look like this right here, it'll have a proper center, proper spread. If it has more skew / outliers, then we would have a different center, different spread. The spread for normal is going to be the mean, and the spread for more skewed data is going to be, or excuse me, the center for more skewed data is going to be the median. When it goes to the spread is going to be the standard deviation. We'll write stand-dev, and we'll make it a little more part right here. So standard deviation, and then right here, we have the IQR. It's very important to know what all these concepts are. We're going to go into a little bit of detail on what each is, but the thing is, you will not use all of these. You can always compute them, but it doesn't make logical sense to talk about the median when the data is more normal. And technically, the mean and median are in the same spot, so it's kind of redundant at that point. The IQR is based on percentiles, so if the data is normal, we're actually going to use the standard deviation. So just a brief talk on each one of these. We'll start by talking about the mean. So the mean is the average of all the data. Let's go to our Pokemon data and think about what this means. What does it mean? We'll go to Analyze Distribution. Analyze Distribution. We're going to double click a quantitative variable of interest, like the attack power of the Pokemon. Now we'll click OK. This looks mostly normal. I'm going to stack it. Then I'm going to go to the second red arrow, Histogram Options, Count Axis. Second red arrow, Histogram Options, Count Axis. And of course, as per usual, second red arrow, Histogram Options, color, lightest purple. And with this, we now have the summary statistics, as it says right here, along with the quantiles, which give you the percentiles in the data as you go from the lowest, the min, to the maximum attack power of Pokemon, and the 50th percentile. Now, you should be able to see a lot of the values, like the mean, the standard deviation, and the median. If you don't see certain values, you can make a lot of them appear by clicking the red arrow, which is where all the options are at, and scrolling down to Customize Summary Statistics, so you can edit them. When you go to Customize Summary Statistics, you could include things like the interquartile range, the IQR, along with things like the range of the data. It doesn't hurt to add on something like skewness. Can you tell what Monster Man this is? If you take my class, we talk about Monster Man all the time. That's a right to the high monster man, which indicates positive skew. Positive skew means right skew. So we talk about the monster man right here. That's a non-monster man. The monster man is right to the high, left to the low, whatever way the monster man's tail goes. And of course, we have to draw him out every time. So monster man looks like this right now, and there he is with his right skew, looking back there at the tail. So that is a right skewed monster man, right skew. So it is positive skew, right to the high. That's high skew, and it's right skew. A lot of synonymous ways to talk about it, just pulled to the high side. So we have tons of summary statistics right here that tells a lot of information, but let's start by talking about the mean. Now, why am I talking about the mean? This is mostly symmetric. I'll tell you this much, every assignment we've done has always been very, very obvious. This one, some statisticians might disagree on which one to use. And you can actually see a big deviation between the mean and the median, big, 4. There's outliers, right skew. I'm still going mean. Not all data will look like this. Remember, we're determining the right, center, and spread based on the shape. Due to the way my data looks, you're only going to hear me talk about the mean and the standard deviation as the metric of center, which the center is where it's at in the middle, and then the spread is how it deviates from that, which is what a standard deviation means, how much things standardly deviate from the mean. So let's go and look at this. The average attack power of Pokemon was 79, which is the mean of the data set. So the average is the mean. And remember, once again, I'm only interpreting this because my data is normal, so the center is best represented by the average. And don't copy everything I say. Don't write word for word, the center is the best measure. No, think about it. Take it in. Just breathe it in and think about it. Center means the middle. So because my data is normal, I'm using the mean as the measurement of center, and this is the average Pokemon's attack power is 79.00125. The spread, because my data is normal, is going to be the standard deviation. The standard deviation tells us the typical difference away from the mean an observation is. So the standard deviation gives us a typical difference from the mean, or typical deviation from the mean. And Pokemon typically differ from the mean by 32.45. That's like a standard deviation. They typically differ. That's what standardly differ means. And the equation, if you look at the standard deviation equation, actually has in it, we'll draw it out here real quick, the deviation from the mean. The standard deviation formula would be the sum of the differences between an observation and its mean. So that's the observation and mean. We square the differences, and then we divide by n minus 1. We're doing sample standard deviation, and we square root it to bring it back to the units of the problem. So that is standard deviation right there, S, sample standard deviation. And if you do sigma, it's even easier because then you divide by capital N. For anyone wondering, mathematically dividing by smaller denominators makes the equation bigger. And when you have a sample, you have less understanding. So we do kind of a increase to the overall variation of the data that gets smaller as you have larger sample sizes. The equation will approach the true standard deviation sigma as you get larger and larger sample sizes. So small sample sizes have a bigger kind of unknown understanding with the n minus 1. That's why n minus 1 exists. Don't worry, it's not on the test. But what you should know, and I will mention this again, is that we're asking how far do these observations differ from their mean? And if you look at it, it's basically an average deviation. The reason for squaring them is to make them all positive, and the reason for square rooting them is to bring them back to non-squared units. Squaring things that are negative make them positive, so these are all real differences. A lot of that just to say, once again, all of this is the typical difference something is away from the mean. That's what a standard deviation is. How much do things standardly deviate? I feel like it's one of those concepts people never understand about stats, but it's one of the intro topics that I love. So that's when data is normal. We use those two concepts. Well, what about if our data was skewed? I might need a different data set for this. I was hoping it would be skewed. Let's go to the, I think you're doing diamonds, so I'm not going to do diamonds. Let's go to movie rankings. Open the jump data. That's not movie rankings. Movie rankings. Gross sales. Oh, if I'm going to be shocked if this is not extremely, extremely skewed. Yeah, if you use the mean, the median here, I mean, if you use the mean standard deviation here, we're going to have problems. That is a major problem. This is as skewed as data can get, and I'm pretty sure the data is in millions of dollars. So do you think the average film or just your typical film makes $13 million? No. A better measure of the typical film is going to be $170,000 or $176,000, which is obtained right here. Remember, this is in millions of dollars to this unit. So the reason we're no longer talking about the mean is because the mean is being highly influenced by outliers. Outliers greatly influence the mean. Outliers don't have as much impact on the median, which is the proper measure of center for extremely skewed data. So the median represents the 50th percentile of movies, which is being used because the data is so heavily skewed to the right. And with this, we would say that 50% of movies make $176,545. 50% make more than that, and 50% make less than that, because this is the median. And remember, this is in millions of dollars, so you just think of that as $0.1 million or so. And once again, we can edit the summary statistics here by going to customize summary statistics and choosing the IQR and other metrics like the range or the skewness, which is going to be a very positive number. There it is right there. And the IQR is 3.4. Now, how is that obtained? The IQR is the range of middle 50% of the data. So we go to the 75th percentile right there, 3.42935, and subtract from it the 25th right here. So the IQR is the range between the two numbers. So the range of the middle 50% of movies goes from $22,000 all the way up to $3.4 million, which means the IQR is $3.4067 million. The range of the middle 50% of movies goes from the 25th percentile of movies, right down here, to the 75th percentile of movies. And so it's very important to be able to interpret and understand these summary statistics and know for the following, for the top graphic right there, you 100% need to use median and IQR. For this bottom graphic, it seems appropriate, and a few statisticians might get mad at me. That's all right, that's all right. But it is more plausible with the bottom graphic to use mean and standard deviation. This does have a little bit of skew. No data is perfect. Nothing's perfectly normal. But if anyone said to use mean and standard deviation up here, then no. So normal data, mean, center, standard deviation spread. Skewed data, median, center, IQR spread. And it looks like the following when you graph it out. So the median is once again going to be at the center, and it's not going to be impacted by outliers. So the median would be the center over here, and the IQR is the range of the middle 50%, which is where the middle 50% of the data is contained. That might not be perfect, but it's close enough. So this is kind of a decent visualization now on the screen of what it looks like when we talk about the spread of the data, which is this distance right here. The spread is the distance, like this is a typical deviation, and we go out 3 standard deviations on the curve. So we have a typical distance from the mean, which is the standard deviation, and then this all over here is based on percentiles, like this is the 25th percentile to the 75th, and the median is the 50th. So all these metrics right here are based on percentile. So very important thing to realize, where the formula for the standard deviation is based on the mean, and the mean is the mean. So these are paired together because the formula that creates standard deviation is literally a standard deviation from the mean. So there's a lot of ways to realize how they go together. First of all, it's just writing it down, practicing it, saying it, and then the deeper levels of understanding that median is a percentile, IQR is based on percentiles, differences in percentiles of 25th and 70th percentile, and then the mean is y bar, and the formula for the standard deviation is using y bar to figure it out. So it's literally how far do things standardly deviate from the mean. And last thing to say right here, and we've repeated this a few times, you really should not use the mean and standard deviation for skewed data. That's a lot worse than using median for normal data. It's redundant, Rock would say. It doesn't matter. It'd be redundant. We don't really need the median for normal data because the mean is where the median is. And a lot of people like to talk about the average, like the average runner, the average price, things like that. You hear average all the time. So it's all, if you say median, then someone's like, wait, what's median? And you're like, it's the 50th percentile. It's, you go through half the data. If there's no half, then you average together the two middle things. So you want to make sure you understand when to use the right measures of center and spread. And the big thing, as we've drawn out right here, is it's based on the shape of the data. So when you figure out the shape, things you'll talk about with shape would be things like the modality of it. Shape has in it modality. I wish I knew how to spell. Modality of shape. Modality is like unimodal, bimodal, multimodal, uniform. You have your skew. Skew can be right skew, left skew. That's a horrible left skew. Left skew or symmetric. And it could be other types of symmetric too. You have here outliers and gaps. That just occurs when you have data and then there's a big outlier and gap right there. So this would be the outlier gap. This would be the right skew, the left skew, the symmetry right there. And then the modality, multimodal, uniform. So understanding these topics right here, that shape is broken up into a few ideas of the modality of it, the skewness of it, the outliers, all these things make up the shape. And once you determine the shape, if it's more normal without extreme outliers, mean and standard deviation. If it's more skewed with outliers, median and IQR. Head back to the main screen. Well, I did some morning office hours and I did some in-person office hours and got everything saved right here. I might go grab a snack because now I got a meeting and it's a slow day. I think it's one of those, like, the third week hits and people are like, they're like, but I want to say this, if you're watching this right now, I think tomorrow will be a really big day on chapter 3, and I'm going to tell people after class. We're going to start office hours pretty much right after class tomorrow, and I'll be like, you need to come in, do chapter 3, get it done. Don't wait till the end of the day. Don't be like, it's late in the day, I'll do chapter 3. I'll do chapter 3. Classes, I'll wait till 5 p.m., 9 p.m., 10 p.m., and then you're like, how do I do this? See, I have no idea. This is impossible. We didn't learn this. There's a few tough ones. There's a few like tough, challenging ones. And yeah, I would say the 100% key is start early. I've said that a lot of times, I know, but starting early, getting it done, really the way to go. Like, you have to start early on a lot of stuff because you'll just get stuck. If you'll get stuck and it'll be late at night and you'll be like, I got no idea. You'll say, I am completely stuck. I am lost. I have no idea how to do this. And then you'll say, well, I guess I'll just take the L. I'll not get a good grade. That's all right. It happens. I got a lot of bad grades. We did pretty well. A lot of people did Canvas content. It's interesting because I'm looking and I'm like, a third of the class didn't do it, which means they weren't there, which is a bummer. That's all right. It's all right. And let me see. I'm going to sort by grades here. I'm going to get a snack. Okay, good. Let me look at the highest grades. Quiz group 1. Interesting on who is missing it. It's not a pattern I would expect. Oh, I think Carlson's looking for me. Well, with that, we're going to head off. Bye for now, everyone. Bye! We've almost got these new intros ready. We're almost there.
This has been going for like 20 hours. This ends now.